Hello, and welcome back to the second part of lesson 6.1. And we're going to start using the empirical rule in the normal probability distribution to describe some different scenarios and see how it can be used. So our first example 3 actually, says the mean height of 15 to 18-year-old males from Chile from 2009 to 2010 was 170 centimeters with a standard deviation of 6.28. Male heights are known to follow a normal distribution. That allows us to use the empirical rule. Let X be the height of a 15 to 18-year-old male from Chile in 2009 to 2010. And this tells us that X is distributed with N is 170 for the mean and the standard deviation is 6.28. Suppose we have a male and it's the Z-score when X is 168 is, so we would calculate it like this. 168 minus 170 over 6.28. So that would be a negative 2 over 6.28. And that comes out to be a negative 0.32. So a negative 3.2. Here is the Z-score. And that tells us that this male is 0.32 standard deviations to the left of the mean, which is 170. Suppose that we have another male and we know their Z-score is 1.27. What is the male's height? So the Z-score tells you that the male's height is 1.27 standard deviations to the right of the mean. Okay. So if we know it's 1.27, then we don't know the height minus the mean of 170 over the standard deviation of 6.28. So if we multiply both sides by 6.28, we get 7.9756 equals X minus 170. And then if we add 170 to both sides, we can solve for X. And so it looks like he was 177.98 centimeters. We validated that right here. So now let's use the same information to find a couple on our own. So the Z-score, what is that when the height is 176 centimeters? So 176 minus 170 divided by 6.28 is 0.955. So 0.955. This Z-score tells you that X equals 176 centimeters is 0.955 standard deviations to the right, because it's positive, of the mean of 170. B says, suppose that the height has a Z-score of a -2. What would that mean? So a -2, we're going to do it similar to what we did up here to find X. They want to find the male's height. So X is going to be equal to the -2 times the standard deviation of 6.28 plus the mean of 170. And so that comes out to be 157.44 centimeters. And because it's a -2, we know that they were underneath the mean. And so it says, what is the male's height? 157.44 centimeters is 2 standard deviations to the left. Example 4. From 1984 to 1985, the mean height of 15 to 18-year-old males in Chile was 172.36 centimeters and a standard deviation of 6.34. Okay. Male heights are found known to follow as normal distribution. And then in 2009 to 2010, they were only 170 centimeters with a standard deviation of 6.28. So Y is going to follow the distribution for right up here for 1984 to 1985. And X is following the distribution that we just looked at for 2009 to 2010. Find the z-scores for when X equals 160.58. So the z-score for X is 160.58 minus 170 over 6.28 is a negative 1.5. And then the z for Y, which is 162.85 minus its mean, which is 172.36 divided by its standard deviation of 6.34. Is also a negative 1.5. So in our solution, we can see that they both are 1.5 standard deviations below their respective means and in the same direction because they're both negative. So even though the two boys were different heights as compared to the average height during their years, this 2009 to 2010 and 1984 to 1985, they're both 1.5 standard deviations below their mean. So let's try one on our own. So in 2012, there were 1,664,479 students that took the SAT exam. The distribution of scores in the verbal section of the SAT had a mean of 496 and a standard deviation of 114. And so this is how it's distributed here normally. Find the z-scores for X1 and X2, different scores here. So they're both scored under the mean and interpret each score. So we're going to do the z of X1 is 325. And then the z of X2 is 0, that. So X1, student X1 scored further below the average SAT verbal score because their z-score was a negative 1.5 compared to a negative 1.14. Okay. Both sides. Suppose X has a normal distribution with mean 50 and standard deviation 6. So X is distributed with 50 and 6. About 68% of the X values lie within one standard deviation of the mean. Therefore, about 68% of the X values lie one standard deviation would be a -1 times 6, that standard deviation. So between a -6 and a +6 of the mean 50. So if you take 50 and subtract 6, which would be one way to the left, 44, and add 6 is 56. So 68% of the data values should be between 44 and 56. About 95% of the X values lie within 2 standard deviations. So if we take a -2 and multiply it by the standard deviation, we get a -12, and do a +2, we get a +12. So if you take 50, the mean, and subtract 12, we get 38, and if we add 12, we get 62. So about 95% of the X values should fall between the values of 38 and 62. And if we do the same thing for 99.7% of the data fall within 3 standard deviations. So we're going to subtract 3 standard deviations, which would be subtracting 18, and we're going to add 3 standard deviations, which would be 18. So we have 99.7% of our data values should be between 32 and 68. So using the empirical rule, let's look at our try it number 5 here. So suppose X has a normal distribution with mean 25 and standard deviation of 5. So X is normal at 25 and 5. Between what values of X do 68% of the values lie? So 68% is 2 sigmas, okay? So we're going to take a -2 and multiply it by 5. So we're going to subtract 10, and then 2 times 5 is a +10. So we're going to take our mean and we're going to subtract 2 sigma, which would be 25 minus 10, or 15. And our mean is at 25. And 68% is, 68% is 1 standard deviation. I knew that. 68% is one standard deviation. Sorry about that. So 1 standard deviation would be 25 minus 5, or 20, and then the mean plus sigma, so 25 plus 5 would be 30. So between 20 and 30. So right here, between 20 and 30 is where 68% of our data values should lie. Look at example 6. Example 6 says, we're back to the 1994 to 1985 data of the males in Chile that had a mean of 172.36 centimeters and a standard deviation of 6.34. About 68% of the Y values lie between what 2 values? So we're going to, 68% is plus or minus 1 standard deviation. So if we take 172.36 and subtract 1 standard deviation, and 172.36 and add 1 standard deviation. So between 166.02 and 178.87. (166.02) and 178.7. About 95% of the Y values lie between what 2 values? And if you add and subtract 2 standard deviations, we would get 159 right here, 0.68, and 185.04. And then they are going to have Z-scores of plus and minus 2. And then 99.7% of the Y values lie between what 2 values? So we're going to do plus and minus 3 standard deviations. And we would get these two values down here, 153.34 and 191.38. And these scores are going to be plus and minus 3. And we can see that down here on the graph. If we draw this, that the mean is at 172.36. And the one standard deviation to the left is going to be 166.02 up to 178.7. And then the second one is going to be 158.68 to 185.04. And then the third standard deviation is going to be at 153.34 up to 191.38. So this is a -1 and a +1, a -2 standard deviations and +2, and then a -3 standard deviations and a +3 standard deviations. So let's try the last right on our own here for 6.1. It says the scores on a college entrance exam have an approximately normal distribution of mean of 52 and standard deviation of 11. About 68% of the y values lie between what two values? Okay, so this is going to be one standard deviation, plus and minus. So this is going to be 52. So the mean minus one standard deviation is going to be 41. And then 52 plus 11, which is going to be 63. And the Z-scores are going to be plus and minus 1. About 95% of the Y values lie between what two values? So those are going to be 2. So let's kind of draw a picture as we go. Our mean is at 52. Draw down here at the same time. So here's our first one at 41 and 63, and then we're going to have our second and our third. Okay, so 52 minus 2 of the 11s is going to be 52 minus 2 of the 11s is going to be at 30. And 52 plus 2 of the 11s is going to be at 74. So 30 and 74 plus and minus 2 standard deviations. So this will be 30. And then about 99.7 of the Y values lie between what two values? So this is going to be 3 standard deviations. So this is going to be 52 minus 3 of the 11s and 52 plus 3 of the 11s. And I can go back up and copy that. And oops. And then we have a 3. That would be 19. And then get a plus and 85. 19 and 85. 19 and 85. And these are going to be plus and minus 3. So that ends lesson 6.1, all about the empirical curve. 100% of our data lies underneath the curve. If it's considered normally distributed, it will fall into this fashion and will fall into these particular percentages, just how we have it laid out here. So make sure you're kind of using that as a guide as you're answering your homework questions. And then catch me back for lesson 6.2.